Hey guys, so in this video we are going to see what is convergence and what are the requirement of convergence and what are the types of convergence, right? So be there with me in this video. This is Bhayaji and you are watching Bhayaji Gyanwala. So can you tell me or can you guess what does convergent means? What is the literal meaning of convergence? You might have seen convergent lens. So those lens, what they are going to do, if the rays are coming, they are going to converge, or they are going to, you can say, focus on one point. So it is going to be reduce. So in terms of FEM, what does convergence means? So you can see the gap is decreasing, right? So this gap in terms of FEM is called as error, right? So converging means the error is decreasing, and since if the error is decreasing, the accuracy is going to increase, right? So if any function is convergent, or if any model is convergent, then you can say it is limiting, or it is going behind the exact solution. It is reaching the exact solution. Now we know in FEM what we are going to get. We are going to get approximate solutions, and if you have to go close to exact solution, your model should be convergent. So convergent is the key to get exact solution or nearly close to the exact solution. Now I told you what is convergence. Now there is one point. So when you mathematically model any system or any problem, or when you give inputs in the simulation software just like ANSYS, LS-DYNA or Star CCM. So these solvers, what they are going to do, now you know that this is just a simulation and it is a virtual model, it is not actual model. So in this virtual model, let's say if you need to find the stiffness, there is a beam, and okay, so the beam is going to have some stiffness value, right? You can give this force by F is equal to minus kx, and this k is nothing but stiffness, right? Now while simulating, this stiffness value is going to it is taken a bit higher than actual value. And because of this, if the stiffness is high, now can you tell me if the stiffness is high, the model is going to displace more or less? Yeah, sure, it is going to displace less because it is more stiff. So the displacement is going to reduce, right? And what is our solution? What do we find in these kind of models? We find the deflection, right? Now deflection is nothing but the displacement of the nodes. Now if the displacement is going to reduce, then the actual value, can you tell there is more error? Correct. There is more error, right? Now if you have to reduce the error, or you can say if you have to converge the solution, your model should satisfy three conditions. Now what are those three conditions? We are going to see now. Okay, so let's see the conditions to satisfy convergence. The first condition is that the displacement model should be continuous, okay, and it should be compatible with adjacent element. Now in this first condition, there are 2 points. First point is it should be continuous. The displacement model. Please remember, displacement model is nothing but your whatever mathematical modeling you are going to do, or you can say the interpolation function. So the displacement model should be continuous, and the second thing is it should be compatible with the adjacent element. Okay. Now you have a model in which 2 elements are there. So this is your first element, and this is your adjacent element which is near to it. Okay. Now it should be continuous. What does continuity means? This first element and the second element both are near. There is a boundary, common boundary. Now if I take a case where this is the first element and after that there is a space and you have a second element, right? Now there is a gap in between, so the continuity has break since the first condition is not satisfying. So in this scenario the first condition is satisfying, it is continuous. And also it should be compatible with adjacent element. What does that mean? So let me rub this. It is going to distract you, that's why. So these are the 2 elements you can see, and compatible with adjacent element means, see, this is the first element, so I am going to focus on the first element. If I am applying a force on the first element, then this is for sure the first element is going to displace or it is going to deform. Okay, so let's say it is going to deform like this. Okay, right? Now it was like this and it has deformed because of that force, like this. Now the compatibility with the adjacent element means, now if the second element is like this only, okay, it has not moved, the displacement is overlapping the second element, then it is not compatible. Then it is not compatible, right? So if the displacement of first is overlapping the second element, then it is not compatible. What does compatibility means? So if the first element, if it is displacing, then the second element should also displace. So the second element has become like this, something like this. So this is your second element and this is your first element. Now it is not overlapping. If I am pushing, if I am giving force to the first, let's say I am here, there is one more person here, and there is third person here. So to the first person, the force is applied. It will go in front. Just the scenario of your local trains. Okay, it will go front, and then this person is going to push the second person. Now can second person say, "Na, मैं तो नहीं हिलूंगा, तुम्हें जो उखाड़ना है उखाड़ लो." Then that means it is not compatible. But if this person is pushing and the next person also pushes to the next person to the next person, and if the chain goes on, it is called to be as compatibility. Okay, so I hope the first condition is clear to you. The first, let us repeat the first condition. The first condition is the displacement model should be continuous and it should be compatible with the adjacent element. Now let us see the. Okay, now the second condition is the displacement model. Now this displacement model is going to be constant in all the other conditions. So I am writing in short, the displacement model, this is displacement. The displacement model must include, what should it include? It should include rigid body displacement. What is rigid body displacement? Okay, it must include rigid body displacement. Okay, now what is rigid body displacement? The definition I will tell you. Now there should be a condition, or it should exist combination of generalized coordinates such that the displacement at every point has to be same or constant. Now that is the definition I will tell you in more simpler way. This is the element. Okay. Now these are the points. Okay. If I am applying a force here, and if this point is going to displace by 1 centimeter, then the next point should also displace by 1 centimeter, and the next point should also displace by 1 centimeter. So the displacement of all these points has to be constant. If these displacements are constant, that body is called to be as rigid body. Okay, so if it is a rigid body, the displacement at each point is going to be same, or it is going to be constant, right? Okay, let's go to the third point. The third is displacement model. I told you it is going to be constant. Displacement model must include, what should it include? Constant, spelling me na. Constant strain state. Now what is constant strain state? Again I will tell you the definition. They should exist the combination of generalized coordinates, and the strain at each point has to be constant. At every point it has to be constant. Okay, the strain at every point has to be constant, just as the displacement in the second equation. Okay. Okay, so we were on the third condition of convergence. Displacement model must include constant strain state. Now what does constant strain state means? I have told you. Now let us see, I will explain you how. So there will be points just like displacement we have discussed before. So at every point, let's say at this point, because of some force, there is some strain. So what is strain? Change in length by dl by L, right? This is your strain, you can say epsilon is equal to dl by L. So it has some value, let's say 0.1. Okay, so for this point if it is 0.1, for this point also it should be 0.1, for this point also it should be 0.1, for this point also it should be 0.1. So this is what constant strain state means. So at every point the strain has to be 0.1. Now the next topic is coordinate systems. So if you have seen my truss video, in that I have explained shortly that how many types of coordinate systems are there and what is a coordinate system, right? So coordinate system, we use coordinate system to show the position of the element. There are basically two types of coordinate system. One is local coordinate and other is global coordinate. So first let's see local coordinate system. Now what does local coordinate means? Local coordinate basic key point is the axis, or you can say origin, should be or will be on system, okay, or element you say. Okay, so element is our system. Okay, we are studying about elements, so that will be our system. So if I am taking a pen, right, let's say this is a pen, and if the axis is here, this is your y, this is your x axis, and this is your origin. So the origin is there on the element, so it will come under local coordinate. Second is global coordinate. Okay, global coordinate. So why do we use global coordinate? Let us say you have 2 or 3 elements, more than one element. You have one element here, you have one element here, you have one element here. So it is not possible that every time you take the axis on this element. So for this element the x and y coordinates will be different. For this, the x and y coordinates, let's say you are taking the local axis here. So your x coordinate is 1, y coordinate is 1. Okay, and when you change the axis from this to this, again your local coordinate is 1, your x coordinate is 1 and y coordinate is 1. So how do you differentiate these two? These two are actually at different positions, but the coordinates are same again. So in order to solve this problem, we use global coordinate system. So what happens in global coordinate system? You are not taking the axis on the element, it will be somewhere away from the element. Okay, not always but usually it will be away from the element. I will tell you the second case, okay? So in this case it is away from all the three elements, right? So this is your 0. Let's say this is this x is 10, this is 9, this is 11, this is your y, this is your 9, and these both are at 10. So can you tell me what will be the position of this? X is 10 and y is 9. Position of this, x is 9, so you write 9 first, y is 10. Here x is 11 and y is 10. So these are the coordinates, global coordinates, because the axis is away. Now I told you it may be away from the element. Is there a situation in which the axis will be there on the element? Yes, there is a situation. Let's say again we take three elements. So this you have these three elements. One is here, here, here. Now I am taking the axis on this element. So for this the point coordinate is 0, 0. Let's say this is at x equal to 1, this is at x equal to 4, and this is at y equal to 3. Okay, so what will be the coordinate of this 0, 0? Coordinate of this will be x is 1, y is 3, and coordinate of this x is 4 and y is 3, right? Now in this the axis is there on the element, but if you consider all the three elements, for these two elements the axis is away. So this is also the example of global coordinates. So far I have told you, in this video we have covered convergence, condition for convergence, and the types of coordinate system. So in the next video we are going to what will we see? In the next video we are going to see types of convergence. So we studied convergence, we will see types of convergence. Be there with me. This is your Bhayaji and you are watching Bhayaji Gyan Wale.